when I started, they had just had a newborn.
Oh,
So
wow.
I started with him, and now he just turned 2 on Monday.
Oh, wow.
So yeah, I'm like toddlers and stuff, but like
I like
really
8-year-olds.
kids
8-year-olds
kind
are
of
fun.
scare me. I have a 2-year-old and a 4-year-old, and they're both boys.
Oh boy.
They're
Okay.
wild.
So, here's our packet for today. And I must really love y'all. No, I'm just kidding. It's just because last night. So,
That sounds like me, Miss Jennifer. I procrastinate.
And so it's happened that we had last week off. I should have done this last week, but I didn't. I did it last night and didn't go to bed till 3:30.
Oh no, hey, it's okay. That's
So-
how most of our
Yeah.
friends.
So as I get older,
Like I was trying for my algebra 2 homework. I was trying. Okay, so I'll do this portion of the homework on Monday. This
Yeah.
portion of the
Oh,
homework
that
on
does-
Tuesday.
that does-
Oh yeah, no, I didn't even.
And
do
then,
that.
and then now,
I can't
but
get it
on
done.
Tuesday I work from like 12 to 6. So I'm like, how am I supposed to get it done?
okay. So we'll go ahead and get started, and let me share my screen and we'll go through this stuff. So basically the last bit that we've talked about science, we have talked about the types of passages. We've broken them down. We've looked at the different types. Is it interpretation of data? Is it a research study? Is it conflict viewpoints? What are we looking at to be able to figure out how to approach the passage? Now we're going to be looking at the reporting categories. And so like one of the things, so my daughter had taken the ACT in October and we got her scores back last week. So science was her lowest category. And so, but the way that the report is broken down is it's broken into the 3 reporting categories. So now we know that, hey, her lowest area within the reporting categories was dealing with the first section that we're going to talk about, interpretation of data. And so by looking at that, we're going to be able to kind of break it down more and say, hey, as you're taking the test, this is what you need to focus on. This is what you need to understand about these graphs and charts and how to relate what you have read. If you look at it in a list form, if it gives you a table and you have to apply it to a graph, things like that. So, so these are going to be the things that we're looking at today, is starting with the interpretation of data. Let me share my screen real quick. There we go. Okay. So, and at least, I mean, you won't be able to read it perfectly on the screen, but at least you'll kind of be able to see if I highlight something, what area. All right, so it says on the ACT Science, there are 3 reporting categories. Reporting categories are the content on which the questions are based. Your understanding of the process of science and how data is used is tested rather than your understanding of scientific content. So they're not expecting you to know everything about physics and biology and chemistry. They're not expecting you to have this in-depth knowledge. They're just expecting you to be able to look at how information is presented and be able to understand the data that is being presented there. The passages will all come from different subject areas of science, and you will be assessed on 1, interpretation of data, 2, evaluations of models, making inferences and experimental results, and 3, scientific investigation. So today we're going to talk about the first 2, interpretation of data and evaluations of models, inferences, and experimental results. So it says science subject areas. Here's a list of possible topics you will see in science passages. Remember, you're not expected to have in-depth knowledge of these topics. If you need to understand anything specifically, the passage will give you the information that you need somewhere in the passage. Sometimes it may be, it'll give a word and it'll give parentheses and tell what it means. Sometimes they may give you the information, they may give you information that you need to know in the question. And it may be understanding that something, then whatever. So they're going to give you, if there's scientific knowledge that you need to have, they're going to give it to you. So in life science, you may experience passages about botany, cell biology, ecology, evolution, and genetics, not in the evolution in the sense of like monkey man, that kind of stuff, but maybe the evolution of a I don't know, plant species or something like that, not people. Physical science, and that's one thing to note, that ACT stays away from controversial stuff. Okay, they're not going to be giving anything that's going to like spark a debate or whatever. So know that they're gonna stay away from anything controversial. Physical science, acids and bases, kinetics, properties of matter, and thermochemistry. Physics includes electromagnetism, fluids, mechanics, optics. And earth and space science, astronomy, environmental science, and geology. So for the reporting categories, interpretation of data, you can see that 45 to 55% of the science test is interpretation of data. So this is the most important category to understand, okay? And this was the reason my daughter's score in science was lower than she expected it to be, because this whole category, she did not realize that this was an issue that she had. Now we know, so we'll work on it. Okay, it says this category assesses your ability to manipulate and analyze scientific data presented in the tables, graphs, and diagrams. You must know how to recognize data trends, to translate tabular data graph, and we're going to talk about all this just stuff in a minute. I've got definitions to help you understand. How to translate tabular data graphs, how to interpolate and extrapolate, and reason mathematically. So now in parentheses, I've told you what you need to know. Tabular data just means data that's structured in columns or rows, okay? So if you think about, thank you. So tabular data, hey, come in. I'll let you take that. Thank you. So tabular data means it's in columns and rows, okay? Interpolate means, interpolation of data means that you can estimate a value that's between two known points. So if it says that something is, if you're having to look at on the graph, it tells you that this point is 5 and this point is 3, then you can interpolate that the one in between is 4. Does that make sense? Whereas extrapolate means you're going to estimate a value that's outside the known data points. So maybe they've given you a graph and you have to make an inference about what the next data point would be off the graph extending beyond. Okay, so that's what interpolate and extrapolate means. Interpolate means that I need to estimate something that would be on the graph that would be between two data points that are on the graph. Extrapolate means that I'm going to have to go beyond what's on the graph. Okay, but I use the trend in data. I can see that as things are increasing, as this number increases, this increases. Therefore, I know that if I'm going with a value that increases beyond what's on the graph, then I know it's going to increase the other way as well. The second area, evaluation of models, inferences, and experimental results, is going to be the second content area. 25 to 35% of the test is made up of these types of questions. This category requires you to judge the validity of scientific information and formulate conclusions and predictions based on the given information. The example I give is to determine which explanation for a scientific phenomenon is supported by new findings. So if you see we're through several different experiments, that experiment 1, experiment 2, experiment 3, they all have the same kind of finding, then you can infer that the scientific, the investigations were valid. You can look at it and make conclusions about, okay, well now if we did another one, what would you expect to find? The last one is scientific investigation. And this says this category requires you to understand experimental tools, procedures, and design. Identifying variables and controls. Remember, variables are items that are going to change. Controls are things that stay the same from experiment to experiment, okay? And compare, extend, and modify experiments. So predict results of additional trials. So that one we will cover week after Thanksgiving when we're back virtually. We'll do our third thing about scientific investigation, and we're also going to investigate the scientific model in depth to have a better understanding of the model of investigations. So it says these categories focus on the process of science and how scientists investigate. You're expected to be able to look at scientific information and draw conclusions or make predictions about experiments. You are expected to understand ways that experiments are conducted, how they're designed, and how they can be changed to look at new phenomenon. You must know how to look at data in a graph or table and analyze in depth. Okay, so again, you do not have to know specific in-depth scientific information. What you need is going to be given to you in the passage. You just need to know how to take that information and make inferences, draw conclusions, apply it to the charts and graphs. All right, so next page says each of the three categories is broken down in different skill statements describing specific skills you should be able to do within each reporting category that we will now look at. So the first one, interpretation of data. This is the most heavily weighted category of the ACT science test. As previously described, you must manipulate and analyze scientific data presented in tables, graphs, and diagrams. You must know how to recognize data trends, translate tabular data graphs. What did we just say a tabular data graph is? What does it mean if it's tabular? How's it organized? Charts and columns. So think about an Excel spreadsheet, okay? If you've worked in Excel before, that's considered tabular data. It's arranged in rows and columns. So the word tabular, when you see that, you're just thinking about, okay, I'm thinking about a table. I'm thinking about information that would be expressed like in Excel. Interpolate and extrapolate, that's what we just talked about. Interpolate means I'm going to figure out something between 2 points. Extrapolate means that I'm going beyond what's on the graph and reason mathematically. You're not simply looking at a chart and identifying information, but you're also having to understand the data trends to determine where a value or measurement might fall on the graph as well. You may also have to identify patterns and relationships shown in data represented in a graph. You will be expected to look at a table and compare it to data shown on a graph and back. You might need to look at a single graph, or you may be given graphs as answer choices and be expected to determine which graph best represents the table that you see in the passage. So here are our 6 most used skill statements. So basically I have 6 of these that we're going to go through in depth. We're going to break each one down. So the first one is to determine how the value of a variable changes as the value of another variable changes in a data representation. Okay, so basically look at how one changes compared to another. 2, compare data from a data representation. How can I compare if I've got it represented in a chart? How can I compare what's being represented? Compare data from 2 or more data presentations. So basically, if I have a couple of charts or diagrams, I've got to be able to look at them and really see how they are related. 4, determine and or use mathematical relationships that exist between the data. So it may be, there's actually one that we'll go through that we have to look at. It's got tabular data. So basically it has column A, column B, column C, and you've got to look at it and it's asking how maybe column C is related to A and B. And when you look at it, you can see that A plus B equals C. Okay, so sometimes you may have to look and say, are these numbers being added together? Are they being subtracted? Am I dividing? Am I multiplying? So when it talks about mathematical stuff, we're not talking about anything major, anything that's going to require like in-depth mathematical knowledge. It's just basic operations. How can I relate information together using the basic operations of math? 5, translate information into a table, graph, or diagram. And 6, analyze presented data when given new information. So we're going to start with the first one, examples of skill statements with sample passages and questions. So the first one is, examine how the value of a variable changes as the value of another variable changes in a data presentation. And so after each of these, I've put, okay, so that's great and wonderful that you've told me that that's the skill statement, but what does that mean? Okay, so I put, what does it mean? You're going to be shown a graph or a table with 2 or more sets of data, and you're going to need to be able to determine a relationship between them. So immediately when you're looking at a graph, look at it and say, hey, as one value goes up, does the other one go down? Or does it go up? Or does nothing happen? Is there no change? So you're looking at, as one increases, decreases, does the other increase or decrease? What's going on here? Okay, so I wonder. Why have I not done that before? Why am I so dumb? Oh my goodness.
Well, like that one saying, you'll learn something new every day.
I know. Now I can just lower. It might be a little bit better. Let's far down. So let's go down here. And it won't be perfect, but at least it'll be better. Move this out of the way now. Go away. All right. It won't be perfect, but at least it'll be a little bit better. Okay. So what we're going to have to look at, and so, you know, I had to do a little cutting and pasting here. So the first part says passage 1. Okay. So if we're looking at this one, this is where we're having to examine how the value of a variable changes as the value of another variable changes. So passage 1. So it says flood basalt plateaus are large areas on Earth's surface covered with a thick hardened lava. It has been hypothesized that the huge outpourings of lava that form these plateaus were produced by plumes of molten material rising from deep within Earth. Now you may have no clue what the word plumes means, but you can understand by using the context. It says molten material rising from deep within the Earth. So we all, you know, when we were little and we learned about volcanoes and stuff like that, we know about the molten material below the Earth and it rises up. So we can kind of have that visual there. We may not know what a plume is, but we can see it would be something that would be coming up from down below. So then we can see here, we have study 1. This would all be related with the same thing. So it has study 1, and it says a model of a typical plume was created using a computer. It was hypothesized that the head of the plume produced the flood basalt plateaus when its molten material reached the surface. Figure 1 shows the computer-generated plume, its diameter, and how long in millions of years. So that's what the capital MYR is representing, millions of years. It would take the head of the plume to reach the surface. Okay, so we can see they've taken this diagram. It's telling how many millions of years it's going to take this molten lava to reach the surface here. Okay, so the main thing, the first thing I look at is I look at each of these descriptors in my graph. I'm looking at on my left side, on my left axis, I'm noticing that I'm looking at depth in kilometers. On my right side, I'm looking at the time that it takes to reach the surface, okay? Down here, I can see the diameter. So I need to take in each of these different pieces of information. So, yes, thank you. And then my elevation, you can see here in kilometers is going to be, elevation will be what's above surface or above 0. My depth will be below 0. Okay, so I can see that point where it crosses over, where it reaches the surface. Okay, and so one of the things I can look at that and see is that my diameter is going to increase where? Where does it start to increase? The further away from the surface or closer to the surface? Closer to the surface. As it's going up, it's starting to spread out. So when I look at that chart, even though I may have really no clue what in the whole wide world they're talking about, I can look at that chart and I can see at the depth, it's going to be thinner, it's going to be skinnier. When it reaches the surface, right before it reaches, it's going to be wider, but then as it goes to the surface, it narrows a little bit more. Okay, so even if I have no clue what it's talking about, I'm sorry. Yeah, it does look like a spoon, doesn't it? Okay, so they've kind of given it a name of a head and tail. So you know, so also by looking at head and tail, you know the direction of the movement, and they've even labeled that for us. They've said, hey, the direction of the movement is up. So by looking at what they've told us and being able to look at it and just say, hey, how are these things related? Okay, as the surface, as the depth goes up or reaches elevation, we can see that we have a change in diameter. All right, so then it tells us also at the bottom, it says, you know, where the figure comes from. We don't even have to worry about reading that information. The other thing that I want you to also know, not to get too bogged down in this information and trying to really fully understand the chart in depth. You're just trying to glance at it, look at your initial reaction. What is this? As this number increases, what is this number doing? What is this number doing as far as the time in years? Okay. And so you're not trying to really do anything more than just relate the data. All right, so that was study 1. Now we look at study 2. 4 flooded basalt plateaus, A through D, were studied. The lava volume in cubic kilometers, and they show you that what the little measure means, km cubed, was estimated for each plateau from the area of the plateau and the average thickness of the lava. The length of time lava was being produced at each plateau and the rate of lava production in kilometers cubed per year was also estimated. The results are in table 1. This is tabular data, okay? So we've got a table here. So we can see that we've got plateau A, B, and C. We can look at the age in millions of years. We can look at the volume of lava. We can look at the length of time that the lava was produced, and we can look at the rate of production, okay? So we're comparing these. Now notice, first thing, in years, we can go from 60 to 67, 135 to 192, okay? So we can see that our age, the younger to older. Now, when we look at the lava volume, is there a clear pattern as the plateaus are older? Is there a pattern of volume of lava? There's not really one here. I can't look at that and go, hey, I've got a clear trend here, because it goes from 2 million to 1.5 million, and then it drops even more, but then it shoots up to 2.125. Okay, so you see, it goes down and then it goes back up. So there's not a clear trend there. Same thing with my length of time that it was produced. Not a clear trend there. Not a clear trend as far as the rate of lava production. Okay, so now what we're going to do is we're going to move along and look at study 3. And study 3 says that scientists found that 3 large extinctions of marine organisms had ages similar to those of the formation of the formation of 3 of the flood basalt plateaus: 58 million years, 66 million years, and 133 million years. It was hypothesized that the production of large amounts of lava and gases in the formation of plateaus may have contributed to those extinctions. Okay, so and it says, notice that there's an error here, plus or minus a million years. All right, so what's plus or minus a million years? But so basically it's just saying, hey, they noticed that there were extinction patterns around 58, 66, and 133 million years. So it was hypothesized that the production of the large amounts of lava and the gases may have contributed to those. Okay, so the question says, according to study 2, notice they're telling you where to look. According to study 2, which of the following statements best describes the relationship, if any at all, between the age of the flood basalt plateau and the length of time lava was produced? So it tells us I need to look at study 2. I need to look at the age of a flood basalt plateau and the length of time the lava was produced. Now, real quick, I'm going to glance at my answers. And the first one says, as one increase, the other increases. As one increases, the other decreases. As one increases, lava produced increases, then decreases. So then I've got an increase, decrease. And then J, no apparent relationship. Okay, so we're going to go back and look at the age and the length of time. So obviously, when you've got your study booklet, it's all right there on the same pages, and usually you're not gonna have any flipping back and forth like we're having to do here. So we're looking at age and length of time. Okay, so as the age increases, is there a clear trend in data for length of time? Okay, so we go from 1.6 to 1.3 to 1.2 to 1.7. Okay, so when we look at these, it says as the age of the plateau increases, the length of time was produced increases and then decreases. Yeah, because it says it's going to increase then decrease. Notice from 1.6 to 1.3, that's a decrease. So it decreases, then it increases. So notice the question option says increases than decreases. So when we look at that, that would be one of those tricky answers that you would say, oh, look, it changes, it increases and decreases. Look, this one increases and decreases too, but it decreases first, then increases. So that would be one of those gotcha kind of questions that you'd be like, oh, because it doesn't increase, then decrease, it decreases, then increases. So we can see that that would be a non-answer. J is going to be the answer because there's no apparent relationship. I cannot look at it and see, okay? So it says the skill statement for this category expects you to look at the two variables and compare how they change. In the case of the question, the two variables are age of a flood basalt plateau and the length of time the lava was produced. The question asks you to examine if there is a relationship between these two. You need to look at table 1, which shows the data. Table 1 shows multiple pieces of data: plateau, age, lava volume, length of time lava was produced, and the rate of lava production. When you're answering the question, you only need to focus on the data that you need. Determine the relationship and move on. Don't get bogged down in data that is not important to a particular question. So when they've told you specifically where to look, do not worry about anything else in that table. Only look at what you're supposed to look at, okay? So sometimes that means, just like I did up here when I highlighted, hey, these are the two categories I need to look at. And I could look at this and say, hey, you know, I'm going in time. And then I looked at my, you know, I went, hey, this is a decrease, this is a decrease, but then I increase. So you can write on these tests, do what you need to do to focus on, because it is going to be very visually stimulating. There's going to be a lot of stuff there, and you've got to focus on only the important information that you need for that particular question, okay? So don't get bogged down in other information. Once you've identified the variables, the next step is to see the relationship. You're looking to see if there's a change. Does it increase, decrease, increase, then decrease, whatever. So it says when you look at the age data, you can see that it moves from 60 to 67, then 135, and finally 192. There's a clear trend there, okay? The age. When you look at the length of time the lava was produced, we've already talked through this, so I won't even go through, but it just says, so the answer is J, because there's no apparent relationship between that lava production, okay? Number 2, the second skill question is compare data from a data representation. What does it mean? It says you're, ooh, come back. I guess so. I lost my connection, I guess, because it's not coming up on the screen. Wait, see if we'll come back. Okay, so look at the graph or the table and get you're given and identify specific information presented in the graph, like the highest and lowest value, the order of the data, etc. This is a straightforward category, and there is no interpretation or prediction to be made. You're just reading a graph and determining the answer. So let's look at the passage. Now we'll see if it'll finally go back. Okay, in teeny tiny little print, it says, a team of researchers constructed a greenhouse consisting of 3 artificially lighted and heated sections to be used to grow food during the long space voyage. The researchers found the weekly average light intensity in arbitrary units and weekly average air temperature in degrees Celsius in each section. The results for the first 6 weeks of their measurements are given in table 1, and it says weekly average light intensity, in table 2, which is the weekly average air temperature. So we can see that table 1 and table 2 are going to be similar in that it's showing each week in section 1, section 2, section 3, but table 1 is dealing with average light intensity, table 2 is dealing with air temperature, okay? So we see the 2 different things. So it says the highest weekly average air temperature recorded during the first 6 weeks of the study was. It's telling me highest air temperature. So I'm going to look at the chart that deals with air temperature, and what was the highest temperature?
Section 1.
Okay, so look in section 1. What is your highest number on that graph?
It's going to be 6.
Yeah, so it's 21.13. So when we look at our answer choices, we have 18.47, 21.13, 120.7, or 314.9. Where are those numbers coming from? Where do those last two numbers, 120.7
120 is from section 3 of table 1.
of table 1, and what is table 1 talking about?
Light intensity.
It's talking about light intensity. It has nothing to do with air temperature. So basically, if you're looking at the right table, you're going to know that you're dealing with either A or B. It can kind of trip you up if you're just looking, hey, I'm going to look at the graph and I'm looking for the biggest number on the graph, between the two graphs. So if you're just looking at the two graphs, you can see that 314.9 is the largest number on one of the two graphs, but they told you to specifically pay attention to air temperature. That means do not look at the other one. You can see at air temperature, if you look at all of those numbers, the largest number will be that 21.13. So your answer is B. Okay. Number 3 on the next page, compare data from 2 or more data presentations. So in that one, we just had one data presentation that we had to look at. It said, look at table, look at the air temperature. That's going to be that one table and pick it out and move on. Now, this next one is saying I'm going to have to look at 2 or more different data representations. So it says, what does this mean? You're going to be shown multiple tables, graphs, and both. You'll be shown multiple tables, graphs, or both will need to be compared. I did not word that very well. All right. So in this passage, it says, the following experiments were performed to investigate the effects of adding various solutes, which are substances that are dissolved in a solution. See how they put that information there. They are not expecting you to know what a solute is. So they told you the information that you needed to know, that it is a substance that will dissolve in a solution. And it's in varying amounts, and the boiling points and freezing points of water solutions. Pure water freezes at 0 degrees centigrade and boils at 100 degrees at standard atmospheric pressure. So at regular pressure, 100 degrees, water is going to boil. So experiment 1, a student dissolved 0.01 mole of sodium chloride, which is NaCl, in 100 grams of water. Each mole of sodium chloride produces 2 moles of solute particles, 1 mole of sodium ions and 1 mole of chloride ions in solution. After the sodium chloride dissolves, the freezing point of the solution was determined. This procedure was repeated with different amounts of NaCl and table sugar, which is also called sucrose. Each mole of sucrose produces 1 mole of solute particles, or a sucrose molecule. The results are shown in table 1. All of that information is not something for you to stress about. Oh my gosh, I do not understand chemistry. Okay. When you read all that, you're not going to need to necessarily understand all that. You're going to need to understand the table. Okay. You're going to need to look at the graphic representation of that, where you can see that solution 1, we have substance added to water. We can see that we've got sodium chloride in the first ones. And then we have sucrose, which we found out was just sugar. Okay, so we have salt in the beginning and sugar in the other. And I can see the amount added. Okay, and then I'm looking at freezing points. That's all it is. Hey, I added some salt and it was this much that I added, and this is what the freezing point was. I added this much sugar and this is the amount that it was, and this was the freezing point. That's all it is. So all that information up there, I don't have to understand what it said. I look at my table and understand that I'm adding salt to water, I'm adding sugar to water, that I change my amounts, and my freezing point changes. Experiment 2 tells us that a student dissolved 0.01 moles of salt in water. After the salt dissolved, the boiling point was determined. So here, same thing, I'm adding salt. This is how much I added, and this is how the boiling point changed. All right, so then it says, according to the results of experiments 1 and 2. So in the question, it tells me I'm going to have to look at both experiments. Which of the following conclusions can be made about the magnitudes of the changes? If it says magnitude of the change, it's talking about how drastic are the changes. Are we talking big changes, little changes, no change at all? in the boiling point and freezing point. So we're looking at changes of boiling point and freezing point when 0.2 moles of salt is added to water. That's a key piece of information there, because we know that each table tells us that I'm dealing with a different amount. So when I go to 0.2 moles of salt, the first table I want to look at is I want to make sure that I'm comparing salt at 0.2 moles, and I can see that my freezing is negative 6.9. When I look at table 2 and I look at 2 moles of salt, my boiling point is 102. So when I look at this, I can see that, hey, if freezing is at 0 and I add salt to it, is there a big change or a little change from regular freezing to adding salt? So when I look at my question possibilities, it says, so the base, and we're paying attention to just the freezing point. So I don't even have to focus on the boiling point. I'm looking at the freezing point first. So it said the freezing point raised less than the boiling point is lowered, raised more than the boiling point is raised, lowered less than the boiling point is lowered, or lowered more than the boiling point is raised. So let's look at that. It says the question can seem overwhelming, but once you identify all the information you need, it is just determining the bigger number. The question tells you to look, tells you that you will need to refer to both experiments, look at 0.2 moles of salt. So we looked at that first. The next step is determining which has the greatest amount of change. Okay, the freezing point or the boiling point. So it says the freezing point goes down more than the boiling point goes up. Notice freezing point, if I'm starting at 0 and now I've gone to negative 6.9, okay? Boiling, we said starts at 100 and I've only gone to 102. So I've got a big drop in freezing and not much of a raise in boiling. So if we look at our answer choices, J, the freezing point lowered more than the boiling point raised, because my freezing point lowered 6.9. My boiling point raised 2. So freezing point dropped at a greater value than the boiling point raised. Okay, so again, I'm focusing in, they've told me, they've given me a whole bunch of extra information that I could totally get bogged down on. I could totally go, oh my gosh, I don't know chemistry and I don't know, okay, NaCl and what is this and what, I could get so wrapped up in that and panic instead of going, hey, it tells me to look at experiments in 1 and 2. I'm just going to look at 0.2, compare those two. Okay. Number 4, determine and or use mathematical relationships that exist between the data. What does this mean? You will need to look at data and try to figure out a specific relationship based on what is asked in the questions. You might be asked to find an average of data. Perhaps you might have to look at units, find ratios, see some other type of relationship. You are not expected to solve a complex mathematical operation, and the question should be relatively clear on what you're expected to find or deal with. It's not going to be ambiguous where you have to kind of sit and figure out, oh my gosh, I don't even know what to do here. Okay. So in this one, it says we have students use 2 methods to calculate D. A car's total stopping distance. D is the distance a car travels, the time the driver first reacts to an emergency until the car comes to a complete stop. In method 1, R is the distance a car travels during a driver's assumed reaction time of 0.75 seconds, and B is the average distance traveled once the brakes are applied. Method 2 assumes that D equals the initial speed in feet per second times 2 seconds. Table 1 lists R, B, and D for various initial speeds where D was computed using both methods. Figure 1 contains graphs of D versus the initial speed for method 1 and method 2. All of that could be super overwhelming and you go, oh my gosh, I haven't had physics. I don't know how to do this. But let's look at the table. What's happening with my speed? My initial speed in miles per hour, it's going from 20 to 80, right? Notice my initial speed in feet per second. Again, that's going in the same direction. 22 to 88, 20 to 320, 42 to 408. So I can see that there are relationships in all of these. They are all increasing as each initial speed increases. So does your initial speed in feet per second, R, B, and D. Even if I don't have a clue what R, B, and D are, I can see that they're increasing, okay? From method 1 to method 2. So now, but look at the question, and then you can see you've got this graph here that says your total stopping distance, and you've got this, graph with 2 dotted lines in method 1 and method 2. But look at your question. And it just says in method 1, D equals, is it R plus B, R minus B, R times B, or R divided by B? R plus B. That was a whole bunch of all kinds of physics and all kinds of stuff and data and tables and all kinds of mess to be able to look at it and go, hey, 22 plus 20 is 42, and 44 plus 80 is 124, and 66 plus 180 is 246, and 88 plus 320 is 408. So I've been able to find that answer A and move on. Nothing else in that passage was necessary to answer that question. Okay, so don't overcomplicate things. A lot of times it can even be helpful. It may be that when you look at a passage, that you look at the passage and say, okay, we've got some methods, I got some tables, I'm looking at speed and stuff like that. And you may want to look at the questions first and go, hey, now I go back to the passage to look to see, because it was not even necessary to read any of that information. Okay, so read it if you need it. But look at the question. It just says in method 1, D equals. So when I look at D, I'm looking at, am I adding R and B, subtracting, multiplying, or dividing? And I didn't have to waste any time. I can answer that and move on. Okay.
Basically what I'm learning is like the person that created the ACT was a jerk.
One of the things that they are looking at, and that's one of the things when I did my training stuff, one of the things they wanted to be very clear of is that they do not intentionally try to trick you. They want to see, do you pay attention to detail? So it's the kind of thing where if you're not paying attention to detail, it is easy to be tricked. But their goal is not to trick you. Their goal is to look at, are you paying attention to detail? So and that's hard, because it's the same thing. I feel like a lot of these, I'll be like, that's a tricky answer. Look, they flip-flop that one little thing. But they did that because they were looking to see who's paying attention to detail.
I overthink everything.
Yeah.
And I do stuff that you didn't have to do.
Yeah,
all
you
of
didn't
that.
have to make, yeah.
I'm like,
Yeah.
Because I would get so confused.
Uh-huh. All right, number 5, translate information into a table, graph, or diagram. So it says, what does it mean? You will be expected to look at some amount of data or information. I'm on the next page. And identify a correct recreation of the data in another format. You might be shown a graph and be expected to determine the correct tabular representation. So look at it in a table. You might be shown a paragraph with an explanation of data and be expected to pick out the correct data and the correct graph representing the data. So real quick, go ahead and turn the page and look at your answer choices. Okay, so your passage is giving you this information. It gives you this diagram. We've got these tables and stuff. And I'm going to have to choose a graph that matches the data. Okay, so I'm having to take data and look at the graph. So when I look at that, when I look at my passage, real quick, it says, some of the liquid in a closed container evaporates, forming a vapor that condenses, reforming the liquid. The pressure of the vapor at equilibrium, when the rates of evaporation and condensation are equal, is the liquid's vapor pressure. A liquid in its open container boils when the vapor pressure equals the external pressure. The following experiments were performed to study vapor pressure. So experiment 1, the apparatus shown in figure 1 was assembled. Except for the tubing, the flask was placed in 20 degrees centigrade water bath. After 5 minutes, the manometer was connected and 2 milliliters of hexane was added. So they are not expecting me, I don't have a clue what a manometer is and I don't know what hexane is, but what I can do is when I go down and I look at this, and it says that the hexane was added to the flask from the dropper. Some of the hexane evaporated. The vapor pressure was determined by measuring the height of mercury after the mercury level had stabilized. Additional trials were performed with different temperatures and other liquids in the flask. The results are shown in the table. So they've shown us how they set up the apparatus, and then they are going to show us what the data collected looked like. Okay, so we've got our table. We can see that they added two butanone, I don't know, ethyl acetate, hexane, methanol, and 2 propanol. Okay, we can see at 0 degrees centigrade, the vapor pressure. The main thing to notice here is this table is talking about vapor pressure. Okay, so we can see that at 0 degrees, at 20 degrees, at 400. So I can see that at each degree, I can look and see that they're all increasing. Okay, so I can say from 0 to 20, I go from 35 to 75 to 200. I go from 20 to 70 to 180, 40 to 110 to 250, 25, 90, 245. So you can kind of see the different ones, which are raising more at higher temperatures and which ones are kind of at a consistent pattern. Then it says the second experiment 2, a test tube containing a thermometer and hexane was heated up in an oil bath. Remember, the first one was water. This one's an oil bath until the hexane boiled gently. The temperature was recorded. The external pressure was 760 millimeters of whatever Hg is. This procedure was repeated in a chamber at pressures of 400 millimeters and 100 millimeters. The boiling points of other liquids were also determined, and the results are in table 2. So realistically, I'm looking at table 1 and table 2. I've got the exact same liquids listed, and I'm looking at vapor pressure according to temperature, and I'm looking at boiling points according to pressure. Okay, so I've got to understand what I'm looking at. So now notice my possible answer choices. So it says, which of the following bar graphs best represented the vapor pressures of the liquids from experiment 1 at 20 degrees centigrade? So I've got a whole bunch of information there, but what I'm going to do is I'm going to go to table 1. I'm focusing on table 1 vapor pressure at 20 degrees. They told me specifically where to look. So I can see I go from 75 to 70. So that means I'm going to go down a little bit. Then I go from 70 to 110, 110 to 90, and 90 to 35. So I can see I have a slight increase, a pretty good increase. I've got a decrease, and then a big decrease. So look at each of our graphs. When we look at our graphs, I've got a slight decrease from the first to the second, then a pretty good increase, then I have a slight decrease. So that rules out A. When I look at B, I go a pretty big decrease and then an increase, so that I can see that, you know, between A and B and A and C, I can see that the first two relationships look pretty similar. So I can rule out B and D. So now I'm focusing on A and C. Now the next thing I'm looking at are my next two bars. Notice that I went decrease, increase, decrease.
I think C.
So if you look at C, I see decrease, increase, decrease, and then a big drop. So that's all I'm looking at. So letter C is understanding, and it doesn't even have numbers on my chart. On my graph. It doesn't even tell me numbers to look at. I don't have to worry about that. All I know is I'm relating a decrease, then an increase, a decrease, and then a sharp decrease. Okay. So let's go ahead and take a break. We will come back and we have one more in this reporting category, and then we'll move on to the next one. So are you guys doing anything special for the holidays? I know you're going
We
camping.
go camping in Georgia. It's something we've done since my mom was really little.
That's awesome. I love that.
We go to Pine Mountain, Georgia.
Uh-huh.
I think it's a place called like FD, State Resort State Park.
Okay.
We go every year. It's got like a lake next to it.
Cool.
You can just camp there for.
Where are you going?
Pine Mountain, Georgia. It's I'm trying to think where it's near. It's about like a 4-hour drive from my house maybe.
Mhm.
It's really fun.
That's nice.
I remember like, I believe, I've driven pretty far.
The farthest I've ever driven was probably 4 hours.
The longest I've driven, like I've been in a vehicle, it's like 9 hours
Wow.
from like 2 times actually.
Actually, I drove with my family, like my mom, my dad, and not my dad wouldn't, or no, he didn't come. And then my brother and sister in the back. I drove like, we were stuck in traffic on the interstate, like right by our house, so we thought we were never gonna get there. And then it took us like, we were in the car forever.
Mm.
And
But-
I was on this road where I couldn't see anything. It was like really dark. And I was like, I'm on the road.
Like, the reason we drove that far was Arkansas,
Wow. I've never.
and then another time to
No, we
North Carolina.
drove to DC. to go to-
Oh, wow.
You drove to DC?
I didn't.
We rode a
But,
bus.
Yeah, that's what I remember, like, the last time I went to DC, I
I've
flew
never
Southwest.
flown.
You've never flown an airplane?
I probably did when I
It's
was
just
a
too much
baby,
money, so we prefer driving.
Mhm.
but I don't remember if I did.
This past weekend, I went hiking with my cat.
With your cat. Now, I guess, do you take it on a leash or in a carrier
I put him
or?
in a leash. On a
Okay.
leash. I've been training him to walk like in the backyard
Uh-huh,
because he's been getting out of the house a lot
uh-huh.
because the dogs have a dog door. So he discovered he could get on our deck, so he's been sitting on the deck.
Okay.
And then he figured out, oh, there's another dog door that goes to the backyard.
Oh,
And so he got into the backyard and he just kept trying to get out.
yeah.
Then we got an electric dog door that opens with a dog's key on their collar.
Okay.
And he's figured out the noise it makes when it unlocks, so he would slip out behind them.
That's hilarious.
Cats are creative.
Now he has a shock collar.
Hilarious.
So I decided it would probably be good to get him outside since that seems to stimulate him a lot.
Yeah.
So I started training him to walk on a leash.
Oh my goodness.
And he's still wonky with it.
Yeah.
Like he lowers
Our
his
cat would
back
just
half of
lay
his
down.
body really weirdly.
Uh-huh.
But he's started to enjoy it a lot and going outside, and he hasn't escaped since.
That's funny.
So yesterday I brought him to Oak Mountain, and we did the Peavine Falls Trail.
Uh-huh. Taking your
We
cat
only
on
went
a
to the
hike.
small one, the small waterfall, but he really liked it. Like on the way back when I was walking to the car, he started crying. And
Oh,
anytime I
yes.
turn around, he'd willingly walk backward. But then whenever we go forward, he'd stop and he'd start crying.
That's too funny. Yeah, we'd always laugh because our cat, when I was growing up, I put a leash on it and it would just drop to the ground. She'd just lay down.
That's
So
what
we'd
he
always
did
say
at
we were
first.
taking the cat for a drag.
Yeah, I
Took
hiked with
the cat to Oak Mountain on a hike on a
him.
leash.
He really liked it though. He had a great time.
That is awesome. I love
He
it.
actually, at one point, he got in the water like shoulder deep. He's like a dog. He's grown up with a dog. And, oh my
Like we tried to
gosh.
make her indoor cat, that didn't really work out. Mom was not doing the whole
Yeah.
litter box thing.
Oh my
So
gosh.
I made a long time ago, like a rainbow balloon collar for her. Next time I saw her, it was gone. And
I
I was
got
like,
you.
what did you do with that?
That's too
That is
funny.
the funniest thing ever.
That is funny.
Oh, man.
That's very funny.
He was having a great time though.
I love it.
Where did you even get the idea? I'm gonna take my.
I don't know. I've
Like-
seen a lot of people doing it, and
For
it
real?
seems to be very stimulating.
My luck, the cat would like climb up me and it would attack me and it would be wrapped around my head because it would hear something or it would freak out.
Yeah,
and-
he got scared anytime people would walk by us.
yeah.
But we went and there
It would
wasn't a
not go
ton of
well.
people. One lady walked by and she was like, "Oh my gosh, I love that." And then one guy thought we found like a wild cat. No,
Where did
he's
you
just
get a
mine.
harness?
I bought it on Amazon. But
Was it a cat one or was it?
Yeah, they have cat leashes.
Mhm.
Oh,
I did
really?
use one of the dog leashes though,
Yep.
because his harness came with a leash, but it's really short,
Uh-huh.
and so he couldn't
Yeah.
really walk well with me.
It's hilarious.
And he didn't just lay down and just.
He walked willingly with me.
That's too funny.
But also, he's a lot like a dog because he's grown up with my dogs.
yeah,
Okay, that's cool.
that's awesome.
He's very good to know. too.
Funny, funny.
That
All
was
right.
tiny. Did you write that?
Yeah. For geometry.
That's like
Oh my
that girl. What
gosh.
was that girl's name? Austin, and the other one. What was the other one's name?
Yes.
Oh,
Her twin sister, Austin, and
I don't know. Wait, which one had the small writing? Maybe it was Austin that had the small writing.
oh my gosh, I can see them, but I cannot think of what her name was.
Yeah,
Austin
same.
and
What's her name?
it'll come to me in a minute.
That was so
Yeah.
funny though. I was like,
And
dang.
we only have like the front note card on geometry test. So I promise
Yeah,
not to,
like in algebra 2, you have to like have these note cards to take tests, like, and so like you can have like one note card per chapter. So
Okay.
I'm like scribbling like an itty bitty handwriting trying to get
Oh, I
everything
put a
on
whole
there
example problem on one note card
Okay.
for a test.
This was
Oh,
my last one. I
goodness.
didn't read too much on that one.
So the final one in this section is to analyze presented data when given new information. Okay, so what does this mean? This category will give you some piece of information that adds on to something mentioned in the passage. It might be a new fact or hypothesis related to one of the data sets or experiments. The questions will ask you to look at one of the existing graphs or charts and see how the new information related them in regard to the answer choices. You will have to think about the new information and use it to pick the correct choice. So we look at passage 1. This is a question that relates back to that same thing about the flood basalt and the molten lava coming up. So we already know what that's talking about. And so and then study 2 shows us our plateaus and the age and all that stuff. So we won't take time to really go through that. So now we're looking at all that same information, but the question says the scientists in study 3, so I know that's where I'm focusing, is study 3, hypothesized that the larger the volume of lava produced, the larger the number of marine organisms that would become extinct. So as the volume increases, okay, the marine organism extinction also increases. If this hypothesis is correct, the formation of which of the following plateaus caused the largest number of marine organisms to become extinct? So it's saying if the larger the volume production, the more extinction, which of these plateaus, A, B, or C, is going to show that highest rate? So let's look at, sorry, I'm not looking at the answer choices. I flipped back to the, so if we look at letter J, plateau D, because when we look at D, we can see that this is the highest lava volume rate. The highest lava volume rate went with plateau D. When I look at my answer choices, plateau D is answer J. So that's all you're doing. So basically they're saying, hey, given all this information that you already have, what if they had this hypothesis? How would that relate to the data you already know? So again, you're just saying, hey, the higher one has the most volume of lava is D, therefore it would plateau D.
More
Okay.
animals it kills.
Do what?
More animals it kills.
Yep, the more animals. Poor little marine organisms. Okay. But again, it's the kind of thing where looking at the questions, most of the time it's going to tell you where to refer back to. It's going to tell you where to look and what to focus on. So I wouldn't spend as much time going in depth pre-reading the experiments. I would have a general idea of this experiment is about lava. Okay, I can see that it's comparing different areas. I've got different depths. I've got all the information. Pay attention to the tables, to the information presented, and then look to your question. Do pay close attention to your question. Circle, highlight, draw arrows, whatever you need to do to mark that up, just like we did on that one where I said, hey, as this one goes up, this one goes up. So I drew my arrows up. So that way I know what relationship I'm looking for when I go to that table, okay? Focus specifically on where they tell you to go. All right, our second category is evaluation of models, inferences, and experimental results. This reporting category expects you to analyze information and draw conclusions from it. Where the interpretation of data category focuses on having you look at data and pick out information, this one expects you to look at information and draw conclusions. You might be asked to look at a supplemental piece of information, meaning they add something on just like they did in that question. Hey, suppose this, then what? So you may look at another piece of information and be asked to tell how it would tie in to the experimental model or the experimental results shown in the passage. Or you might have to look at multiple experimental models and decide which one best fits, best determines the outcome of the question. So we have 5 skill statements. The previous one we had 6, now we have 5. Determine which hypothesis, prediction, or conclusion is or is not consistent with the data. Determine which hypothesis, prediction, or conclusion is or is not consistent with 2 or more data presentations. So the first one is 1, second one is 2. Number 3, determine the theoretical models, whether theoretical models support or contradict a hypothesis, prediction, or conclusion. 4, determine which hypothesis, prediction, or conclusion is or is not consistent with 2 or more theoretical models. And then 5, explain why presented information or new information supports or contradicts a hypothesis or conclusion. Okay. So now we're going to look at the first one. The first one is determine which hypothesis, prediction, or conclusion is or is not consistent with the presentation, with the data presentation or a piece of information in the text. What does it mean? You'll be provided with some type of fact, statement, hypothesis, or piece of information, and you must compare it to what is in the passage to determine whether or not it matches the information in the passage. Okay, so again, I've got my information here and I've got a really funky looking graph. You're going to see things that you've never seen before. Don't let it freak you out. Just look at what you know. We can see we're looking at altitude. Okay, we can see that that's here. We can see we have atmospheric density, atmospheric pressure, average atmospheric temperature. So we have density, pressure, temperature. Now you can see we have surface, troposphere, stratosphere, mesosphere or mesopause, sorry. And then troposphere, stratosphere, mesosphere, thermosphere. And then we can see that up here, this is incoming solar radiation and wavelengths. I'm not even, it says it's in angstroms. I'm not even gonna worry about what that is. But we can see our different things. We have X-rays and ultraviolet light. We have ultraviolet light that is a little bit stronger. We have ultraviolet and visible light, and then we have infrared, okay? So we can see here where the wavelengths, so this is like from 1 to 2,000, 2 to 3, 3 to 7, and 7 to 1,000,000, okay? So then we can also look and see, based on the arrows, we can look and see where it's reaching the different layers, okay? So what I'm gonna do is I'm gonna go ahead and just look at the question without even looking at anything else. All we did was look at that graph. And so it says, note, 1A is equal to 1 times 10 to the negative 10 meters. What do I know about scientific notation when I have a negative exponent? Am I talking about a really big number or a really tiny number? A really tiny number. I'm talking about a decimal with a whole bunch of zeros after it, okay? I'm talking about a really tiny number. So it says, the information provided in the figure indicates that the air temperature in the troposphere is least likely to be influenced by which of the following wavelengths of energy. So I'm going to focus on air temperature in the troposphere. All right, so I know that I am in this section right here, and then troposphere, change my color real quick. I know I'm dealing with this layer right here. Okay, so I have focused in on where I need to look here. And it says that it is least impacted or least influenced by which wavelength. Well, I can see that I've got 2 arrows in the troposphere here, so I know that it is being impacted by those 2 things. Then I've got 2 arrows here that don't quite get to the troposphere. Which one is least impacted? So I can look and see my answer choices are 1,500, 4,500, 6,000, or 7,000. Which one of those numbers are going to fit within this first category of between 1 and 2,000?
Oh.
Yeah, 1,500. So there's your answer. We didn't even read a single thing about this scientific study. We just looked at the chart. We just said, hey, I see, I'm comparing, I've got altitude, density, pressure, atmospheric temperature. I've got these different layers. And all we did was look to the question. It told me where to look and interpret the information. Okay. So one of the things that I'm going to be challenging you guys to do is, as you're practicing and doing these things, look and see, can you get comfortable enough understanding the data without necessarily having to read all the information and get bogged down in that? That's going to be a huge time saver. Okay.
So like, would we, like, on the test, will we read this big passage, or will we just skim over and then answer the question?
My recommendation is to kind of look at it and kind of skim it and just kind of get a general idea. Do not read it word for word, just look at it. And so if I'm looking at that passage and I can see, you know, the things that jump out to me, wavelength, x-rays, ultraviolet light, I know I'm dealing with light and some kind of radiation, okay? Earth's atmospheres, I'm not even reading any of that stuff. I'm just knowing I'm dealing with the atmosphere. I got types of radiation, altitudes, things like that.
See, I'm the kind of person who, when I take a test, I want to read everything very carefully and like want to examine every piece of information.
And that's one of the things that you are not taking this test to learn something.
Yeah.
Okay. You're not taking this to learn anything about, you know, although sometimes you may go, oh, wow, hi, I never even realized that. Don't get hung up on that.
Yeah.
Don't get hung up on, I've got to make sense of this. I've got to understand it. This is an opportunity for learning. No, it is not.
Yeah.
This is an opportunity for you to look at that graph and tell an answer. Okay. That is it. All right.
I'm just such a slow
I
test taker.
I
like,
understand. Yeah.
I try to take my time and understand everything before I even look at the first.
And so it's the kind of thing where what my recommendation to you would be is look at your graph, look at your question. Then if you need to go back, if you don't know enough information, then you can kind of go back from there. But a lot of times we can look at the question. It tells me specifically where to look in the graph, and I don't even have to worry about other information.
So what do you do if you feel like you're stuck on a equation, but you don't have enough time to actually like
Guess and move on.
Yeah.
Those are the ones. Now, the only main thing is like the, you know, remember we talked about the conflicting passages where we have, or conflicting viewpoints where we have different scientists and there, we are going to need to read those because we have to understand what does this scientist think compared to this scientist think.
Mhm.
Are they total opposites? Are they similar, but this one's just slightly different than this one? So when I'm comparing the opinions or comparing something, when it's the conflicting viewpoints passage, I do need to read those.
Okay.
Data representation, research summaries, things like that. I would have a basic idea of what it's about and go straight to the graph and straight to the question. Look at where you need to focus on the graph, answer it, and move on. If you're not sure, guess and move on. And if time allows, go back to it. Okay, so we looked at that one. Now there's another question that's going along with this same piece of information. The next question is atmospheric boundaries are at a higher than usual altitude above areas that get more direct solar radiation. Based on this information, the data provided, which of the following predictions about atmospheric boundaries, okay, so atmospheric boundaries I need to focus on, would be true if Earth received less solar radiation than it presently does? So what I'm going to do is I'm going back to that. All right. So look at my atmospheric boundaries. Okay. So I'm looking at my atmosphere. Okay. So notice it says,
Where is that at? I see where it says atmospheric density and atmospheric pressure.
yeah, so it's just talking about the atmosphere. Okay. So we're talking about the atmosphere in general. And then it's talking about, so what would most likely be true if Earth received less solar radiation than it presently does? So what do you notice about, so it says the question states in the first sentence that the atmospheric boundaries are higher than normal in areas that receive more solar radiation. So look at look at the first sentence of this question. Atmospheric boundaries are at a higher than usual altitude above areas that get more direct radiation. So the higher the pressure, the higher the altitude. Okay, we're getting this from just the question. So then it says, what if Earth received less radiation? All right. So if
The atmospheric boundaries lessen.
so if altitude increases because of radiation, if radiation decreases, what's going to happen with the altitude? It'll also decrease. Which one of these says that the troposphere, stratosphere, and mesosphere would all decrease?
G.
Letter G. Okay, so realistically, we didn't even have to look at the graph for that. We just had the needed information in the question. And it's just saying, suppose this. They told us what we're basing it on in the beginning, that, hey, altitude increases as radiation increases, therefore, as it decreases, altitude decreases. All righty. Number 2, determine which hypothesis, prediction, or conclusion is or is not consistent with 2 or more data presentations and or pieces of information in the text. You can see here that we are back with our little lava head. And so what does it mean? This skill statement is almost exactly the same as the first, except that it requires you to look at 2 or more data presentations. Okay, so just like the last one, we had to look at the atmosphere and wavelengths and stuff. Now we've got more than one that we may have to look at. We can see that we've got study 1 and study 2. Study 1 has our diagram and study 2 has our tabular data. And then study 3 just has information. So we're fairly familiar with that. We're just going to go into our question. And so it says, if the hypothesis made by the scientist in study 3 is correct, I'm going to need to read the hypothesis by the scientist in study 3. Okay, so if I have not read it, I know that's going to be the place where I need to go to first. So it says scientists found that 3 large extinctions of marine organisms. This was the part where it said it was hypothesized that the production of large amounts of lava and gases in the plateaus contributed to extinctions. Okay, so the first thing I've got to do is understand that the higher the production of lava and gas, the greater the extinctions. So it says if the hypothesis is correct, evidence would most likely be found of another extinction of marine organisms that occurred around when. So now we're looking at the hypothesis of that scientist. Now I'm looking back up here at my table and I can see plateau A around 60 years, B 67, C 135, D 192. Now notice in the information from scientist 3, we have 58, 66, and 133. Okay, so notice 58 would fall in about the range of A. 66 falls in the range of about B. 133 falls in the range of C. Which one of those has not been mentioned yet?
D.
D. So then when I look at my possible answer choices, 77, 192, 250, or 314, G is my answer. So I'm looking at the hypothesis, comparing it to the data in the table and saying, hey, this is the one it's related to. All right, number 3, determine the theoretical models support or determine the theoretical models support or contradict a hypothesis, prediction, or conclusion. That's my comma there. And again, you can go back and read the further in-depth, as you go back, if you want to look at kind of a step-by-step reasoning why the answer is what it is. I put that there for you. So number 3, what does it mean? This category expects you to look at a model and determine whether a statement given to you in a question supports that model. It basically wants to look at some science discussed in a passage and determine if a statement in the question agrees with it or not. You're going to be drawing conclusions about the accuracy of the statement in the question or passage compared to the other information given to you. Notice, I do not have a chart or a graph to look at. I only have information in writing. Therefore, I'm going to need to read. So passage 6 says, 2 students explain why the smoke, a mixture of gases and carbon particles, from burning wood in a fireplace rises up the chimney from the fireplace. They also discussed how chimney efficiency and volume of smoke flowing out the top of the chimney per second for a given temperature difference between inside and outside the chimney is related to chimney height. Student 1 says smoke rises because the gas from the burning wood are less dense than the air that surrounds the fireplace. Because the gases are hotter than the air, the gas molecules have a higher average speed than the air molecules. Consequently, the average distance between adjacent gas molecules is greater than the average distance between the adjacent air molecules, so the gas density is less than the air density. As a result, the upward buoyant force acting on the gases is stronger than the downward force of gravity acting on the gases, and the gases rise, carrying the carbon particles with them. The upward flow of smoke is maintained as new air enters the fireplace, causing more wood to burn. As chimney height increases, efficiency increases. The taller the chimney, the greater the volume of hot gas, the stronger the buoyant force compared with the force of gravity, and the more rapidly smoke rises. Student 2 says smoke rises because wind blows across the top of the chimney. When no wind is blowing, the air pressure at the bottom of the chimney is slightly higher than the pressure at the top of the chimney. However, when the air at the top of the chimney moves at a higher speed than the air at the bottom of the chimney, the pressure difference between the bottom and the top of the chimney is so great that the air is forced upward, carrying smoke with it. The departure of the air from the bottom of the chimney in turn creates a pressure difference that forces new air into the fireplace, causing further burning and an upward flow of smoke. As chimney height increases, efficiency increases. Generally, wind speed increases with altitude. The taller the chimney, the greater the difference in airspeed, the greater the difference in air pressure, and the more rapidly the smoke rises. Based on student 2's explanation, the reason the wings of an airplane keep the airplane up in the air is that air moves at a higher speed. Now, where in the passage did it talk about an airplane? We know that they didn't make a mistake. Okay, we know that they didn't know. This is totally not supposed to be this question. No, there's a reason for it. Okay, so basically you're looking at student 1's explanation and student 2's explanation of talking about what causes the air to rise. So think about when an airplane's in the air, there's got to be some reason that it's keeping it up in the air. So they're saying, is student 1's explanation going to be the one to help or student 2? So it says based on student 2's explanation. So now I know that I'm focusing in on student 2. Okay, I know that I want to look at that. And basically it said, as height increases, as wind speed increases, generally wind speed increases with altitude. The greater the difference in airspeed because the chimney's taller, so the air pressure causes the smoke to rise. Okay, so if that's the information that he's saying, is that the chimney's higher, but up here the wind speed is faster, therefore the pressure causes it to raise, the smoke to raise. Okay, so when I'm looking at my possible answers, keeps an airplane in the air is that it moves at a higher speed above the wings than below the wings, below the wings than above the wings, in front of the wings than behind the wings, or behind the wings than in front of the wings. So think about when we're talking about the chimney, where did it talk about the speed of air with the chimney? Higher up, above the chimney. So they're saying that the speed above the chimney caused it to raise. So which of these would be your answer? Letter F. So you're relating his thought process to an external example, okay? You're understanding the process that he was describing and relating it to a different situation. Therefore, you're drawing conclusions, okay? All right. Prediction or conclusion is not consistent with 2 or more theoretical models. What does this mean? This category is very similar in the previous one, except that you must look at 2 or more theoretical models instead of 1, and will be a bit more involved in its expectation of your analysis. So in that last one, we had that one model to think about. We were doing student number 2. We had to understand what he was saying and apply that to the situation. Now I've got a different situation, and I've got two scientists. And it says a polypeptide molecule is a chain of amino acids. A protein consists of one or more polypeptides. A protein shape is described by 3 or 4 levels of structure. 1, primary structure of a protein is the sequence of amino acids. 2, the secondary structure of a protein is the local folding pattern within short segments of each polypeptide due to hydrogen bonding, which is a weak chemical bond. 3, the tertiary structure, meaning 3, is the folding pattern that results from interactions between amino acid side chains, which are parts of amino acid in each polypeptide. These folding patterns generally occur across greater distances than those associated with the secondary net structure. The quaternary structure, which you can assume is primary, secondary, tertiary, quaternary, quarter means 4, is the result of the clustering between more than one folded polypeptide. Again, I'm reading this and going, holy cow, I got no clue. I didn't study this. I don't know what they're talking about. This is Greek. It's okay. So basically it's saying a protein can adopt different shapes, and each shape has a relative energy. Lower energy shapes are more stable than higher energy shapes, and a protein with a relatively high energy shape may denature or unfold and then refold, adopting a more stable shape. A protein that is almost completely denatured is called a random coil. Random coils are unstable because they are high energy shapes. However, some can renature, adopting more stable shapes. So the more unfolded it is, the more unstable it is. The more folded up, the more stable, okay? So 2 scientists discuss the protein shape. Scientist 1 says the active shape of a protein is always identical to the protein's lowest energy shape. So lowest energy is the active. Any other shape would be unstable. Okay, so he's sticking with one thing. Scientist 2 says the active shape of a protein is dependent upon its primary structure. However, a protein's active shape may also depend on its process of synthesis, the order and time in which the amino acids are bonded together, blah, 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 blah. Look at the question. It says, suppose proteins are almost completely denatured. Remember, that means unfolded, unstable, and then allowed to renature in a way that allows them to have their lowest energy shapes. Which of the following statements about the protein is most consistent with the information presented in the passage? If scientist 1 is correct, then all of the proteins will have their active shapes. B, if scientist 1 is correct, all of the proteins will have shapes different than their active shapes. C, if scientist 2 is correct, all of the proteins will have their active shapes. And D, if scientist 2 is correct, all of the proteins will have shapes different than their active shapes. So when we're looking at this, think about, what did scientist 1 say? Scientist 1 said the active shape is always identical to the lowest energy. So the question says, which of the following statements about the proteins is most constant with the information presented in the passage? So basically scientist 1 saying that it's always going to have its active shape. He kept it the same. So when you look at letter B, it says all of the proteins will have shapes different than their active shapes. You know that's a non-answer. That's an incorrect answer because he said it's going to be the same. Scientist 2 says, in letter C, it says if scientist 2 is correct, all of the proteins will have their active shapes. Well, no, scientist 2 said it depends. So we know that one can be eliminated. And so we're between A and D. And so, so basically this is saying scientist 1 says it's going to be one and the same. Scientist 2 says they are definitely different. Which one goes along with these 2 arguments? A. Why can it not be D? Because scientist 2 says it depends. And letter D is saying it's definitely different. Scientist 1 says definitely the same. Scientist 2 says depends. So when I look at my answer choices, it has to be A, because B, D, he's not being hard and fast on saying that it has to be different. It could be the same, it could be different, okay? So kind of thinking through what they've told you, look at your answer choices, see what you can delete or what you can omit based on what you go, no, that can't be because it has to be whatever. Omit what you can and then look and try to, go between the 2 you have left. Again, there's further information there for you to read if you choose to. Number 5, explain why presented information of new or presented information or new information supports or contradicts a hypothesis or a conclusion. What does it mean? Questions in this category are going to give you some information in the question itself or be taken from the passage. There will also be a conclusion or statement provided, and it will be your job to determine whether the information in the question or passage agrees with the conclusion or information given. The answer choices will potentially ask you to support a yes or no. I put now. Mark out that W. It's a yes or no answer with different reasoning. So let me tell you where. Right there. Oh. Make that say no. Should be a yes or no answer. With different reasoning, so you must pay attention to detail on these questions. It is easy to get the yes or no correct, but pick the wrong supporting information. So again, this is a pay attention to detail, because we will probably have 2 answers that say yes, but then I'll have different supporting details, and I'll have 2 that say no with different supporting details. So my first thing is to decide yes or no, and then figure out, okay, why? So again, I've got my passage here. I'm looking at, quickly, I could just, without even reading all of it, carbon monoxide, cars, higher carbon monoxide levels observed, colder weather. We're looking at carbon monoxide. Experiment 1, we have a hose connected to a tailpipe of a car. So we're looking at carbon monoxide. We're looking at time. We're looking at a 1978 Model X and Y, 1996 Model X and Y. Okay, so I'm looking at, I'm comparing time with 2 older cars and 2 newer cars. Okay, that's all I'm going to look at right now. Then it says the same 4 cars were tested at a temperature of 20 degrees. Okay, so here, this is looking at -9 degrees. Okay, so we're looking at -9, then we do it again, looking at 20 degrees. Everything else is the same except for the temperature. Okay, so again, our time is the same. We have the same vehicles. So it says, do the results from experiment 1 support the hypothesis that at a given temperature and time, the exhaust of newer cars contain lower % of carbon monoxide than the exhaust of older cars? So let's look back at our tables. So notice in the first one, I can see that after time, with the 78, we go 3.5, 4, 4.5, 3.6, 3.2, 3.1, 3.0. So you can see we've got an increase and then a decrease. Same thing with the Model X. We go 3.2, 3.2, 3.7, 7.5, 10, 9.1, 8, 7, 7. So I have an increase and a decrease. Model X and Y 1996, 1.2, 1.0, 1.5, 1.0, 0.5, 0.5, 0.5, 0.4. Notice that we've got kind of that same, we've got kind of a mixture of increases and decreases, eventually decreases, but notice our numbers, we're not going from 3 to 10 and down to 7, we're at 1s and going to 0 point something. Same thing with Model Y. We've got 1, 2, 3, 2, 2, 2, 1. So we've got 2 different models, so we can see that obviously Model X has less carbon monoxide overall. So when we look at it, and also we can see that the 1990s models have less carbon monoxide than the 1970s. So my question says, the exhaust of newer cars contains lower % of carbon monoxide than the exhaust of older cars. So yes, okay, so I can look and say, hey, yeah, they do. The newer ones have less. So I know that I've got yes. So now what I've got to look at is the reasons why. The highest % of carbon monoxide was in the exhaust of the 1996 Model Y. No, so it's G, okay, because it says the highest % was in a 1996 vehicle. No, it was not. It was in a 78 vehicle. So again, if you just looked at it and go, oh, look, that answer says yes, and you circle it and move on, then you've got to look at the second part to make sure it is consistent, that it is a supporting detail that is consistent. Okay? Oh, we got through it. I was worried that we wouldn't make it through all of this because it was a lot of information. So, like I said, I hope it's the kind of thing by looking at these that you are able to notice that there's a lot of information in the science section, but it's not all information that you have to have previous knowledge of. It's not information that you really have to read and digest and understand. A lot of this, especially with tables and graphs, you can probably just get a basic idea of what the graph is telling you, look at the question, focus on the part that it tells you to focus on, and answer the question. The places that you are going to need to read are the ones where you're comparing opinions and hypotheses from different scientists, students, whatever. So save your reading time for the ones, the conflicting viewpoints, okay? Use your others to be able to compare experiments, to be able to look at the data, things like that. So I hope by looking at these types of questions, by looking at what's being evaluated, I kind of hope it takes the intimidation factor out of it. Because if you just sat down and looked at that test and said, oh my gosh, I've got to know physics and biology and chemistry and all this stuff. Well, we just looked at how we were able to find the answers and we didn't have to have any prior knowledge going into it. I just have to know how to find the information in the tables and in the information that's presented, okay? So like I said, I'm hoping, so as far as timing goes, again, save your time. Don't read the whole entire thing. Skim. Look at your charts, look at your data, look at your question to direct you where to focus on and go from there. If you then need to go back and skim to understand better, then you can do that. But anyway, so. All right, so next week, my goal is to get our third reporting category to go into scientific investigation a little more heavily to help you have a better understanding of that. Then we will also look at science vocabulary because there are certain things in here that we've needed to understand what the word meant. So we'll be looking at science vocabulary that you do have to have a general familiarity with, just like if it says hypothesis. If you don't have a clue what a hypothesis is, you're going to be totally messed up because they use that a lot through the test. So it'll be kind of some of the common words that you probably have heard, you know. We'll look at all of that. And then, so we only have 2 more classes left. So we are virtual the week after Thanksgiving. Okay, so we have next week off. We're virtual the next week, so that'll be when we're kind of finished up a good bulk of the science. And then our last class, the first part of it, we will completely finish science. Then the second part of it, we're going to look at every single section and just hit the high points and go, okay, remember, you're doing reading, hit this. When you're English, do this. You know, we'll kind of do a general wrap up. And then it's all you in the test. Okay. So is anybody registered for a test coming up?
I'm about to register for the one in February.
Okay, good. Yeah, and I think the other thing to find out, who all are juniors in here? Okay, so if you're a junior, find out, and I don't know, yeah, if you're a junior, find out through your company, because all juniors in the state of Alabama, I want to say it's March the 3rd. I have that on my calendar. I think it's March the 3rd is when they will be taking it. And so find out how you can do that. Because it may be just like how you go and take your, you know, your regular testing March the 2nd. March the 2nd, I think, is the statewide date that juniors are taking it. So so find out about that. And that's a free option because like I know, and also I think we've talked about this a while back, but real quick, I'll mention there are, I think, 4 tests through the year that are test information release things. December, maybe it's just 2 of them. Let me look at the TLR dates. ACT test information release. December is the last one. The date's 2021. We'll look at 2020 and see. Okay, so actually they've got into 2022 as well, and 2021. So the test information release, June, July, December, April, and June. I think the July one was, they added this year. So I think it's typically April, June, and December. I think are the 3 times that you can take the test. And basically what it is they will send you a booklet that is the same book, the same test series that you took. It's not going to be your exact test booklet, but it will be the same. So if it's like a form 222D, you'll get a 222D booklet. So that way you can actually see the actual test and look at your answers and then be able to compare instead of going, oh, I missed this one. Well, if I just get my regular score thing, like you just see what you, I mean, like you just get a score. You're not looking at, oh, this one was A and you put B. Well, you have no reason why you put B. But the test release, I think it's $22 more. So it does, you know, it's kind of expensive, but it is worth it to also be able to look at, go, and then that way you're able to look and say, hey, this is what I put. What was the correct answer? And go, oh, that's what I messed up on. So then if you're taking it again, the opportunity to remember, hey, I made that mistake. I'm not doing it again. Did I pick yes and I didn't look at my supporting information? Did I pick no and it was, you know, whatever. But anyway, so know that those are options. So that's the December 12th test, your April test, and June of next year. So April, June, and December of next year will be the times that you can get your test booklets to be able to get those. And it's just a good evaluation tool. It's a good thing for you to be able to look at. And I was going to see real quick. I was going to try to pull up a report just to kind of give you an idea of how you can use your information after you've taken it. Okay, so I'll show you the one my daughter did for science. That's what she did very well in reading and English and did terrible on, well, I won't say terrible compared to what she made in science. I mean, made in English and reading, her science and math, but you can see, so the interpretation of data, it shows a score that she got 9 out of 20 correct on interpretation of data. She bombed that. Okay, so now I know, hey, when we work for the next test, this is what we're going to focus on. We're going to really learn how to break down those charts, how to look at the information you're looking for. Now, science investigation, 100%. She got all those correct. They do a lot of science experiments at school. And so she's 100% good on that. But where's she bombed? So when you're looking at your test results, you can look at it and say, hey, this was my strength. This was my weakness. So then you're able to go back to the material that we've gone through. If you're taking it again, sometimes you take it and you get the score you want and you're like, hey, I'm good to go, I'm done. And that's fantastic. You don't have to look back at any of this information ever again. But if you're looking to improve your score, then you can focus in on, hey, I don't need to spend time with her on understanding scientific investigation. We need to work on reading these charts, okay? That's what she's got to work on. Same thing with math. It'll kind of give an idea. Hey, how did you do in geometry? Do you need to review that a little bit more? Was it just basic operations? Was it skills that you learned in middle school that you haven't refreshed on? Or was it a math that you haven't taken and you're not going to take? So there's no point in wasting time studying that. You're not going to get it. you know, or if you really want to get that information, then you're going to have to get tutoring to learn how to do that. So it kind of helps you gauge of where you're going and what you're going to do.
What kind of math is going to
Do it.
What kind of math is going to be on the test?
You've got from basic operations, you know, algebra, you've got pre-algebra, algebra, geometry, a little bit
Algebra 1 or
algebra 1.
is there any trick?
There is a little bit of trig, so you've got it's a very small percentage, and these will all be things that we'll go over on our last day. We talked about all this in math when we did the math section many moons ago, but right now our minds are filled with science. So we'll review all of that and do like a quick little review. I will have, one of the things I'm working on for you guys is kind of having that math study sheet, a little math cheat sheet that says, hey, this is what you need in algebra, this is what you need. So if there's a formula that you need to know, like the midpoint formula, okay, think about in geometry when you've got, or even in algebra 1, when you're graphing and you look at the midpoint of a line, you have your 2 endpoints and you want to figure out what the midpoint is. You've got to add your X and Y values and divide by 2, add your Y values, divide by 2. You need to know midpoint formula. You need to know the distance formula, whereas the distance is the square root of what is it, x1 plus x2 squared minus y2 minus y1, or vice versa. You need to know distance formula. So there's certain formulas and things that they expect you to know going into it. So I will have a sheet for you of all the math things, and you can go through and say, hey, I'm good with that. I'm good with that. Oh no, I need to practice that. So I'm gonna make a little note card. I'm gonna make a study card, you know, to work on those things. So that'll be kind of on our wrap up day. We'll look at all those different things. Okay. Well, very good. Well, we got just a couple of minutes before the bell rings. So any questions, comments?